Hi there, it's Jason Gorman from Codemanship here with a very short video, well hopefully it'll be very short, about manual refactoring. So a lot of the times when I'm training or coaching people, they may be working in languages that don't have refactoring tool support or very good refactoring tool support, so they have to do them by hand. And when you're refactoring by hand, you have to be doubly disciplined really, because the danger is that you just end up sort of meandering into the code and just hacking away at it, and there's no clear start or end to the refactorings that you're doing. The whole point of refactoring is that as much as possible we want to keep our code working, so we want to make one small improvement to the code and then be able to run the test and see the code still works. So it's important when you refactor manually to stick to the mechanics of each of the refactorings and treat each one as a sort of a transaction against the code that has a clear endpoint where you would expect to be able to run the tests. Let's do a simple example here. I want to refactor this slightly complex method. It's got a for loop and it's got an if statement in it, and I want to clean this up a bit. So I want to extract some helper methods here that help me tell the story of what's happening, but reduce the complexity of the individual methods. So now I'm in Eclipse, so if I'm in Eclipse I could very easily just use the extract method refactoring and that would all be done automatically. But let's imagine I don't have an extract method refactoring, I have to do it by hand. How do I do it? Well, the first thing I need to do is I need to select the block of code or the statement or the expression that I want to extract into its own method, which I've done here already. And then I need to identify inputs and outputs, that is to say variables that are referenced inside this block of code that are created outside of it, so they have to be passed in, and also to identify potentially any return values that this method's going to have to return, because these will be variables or values that are referenced further down in the code. So in this case I've identified that sequence is an input. Because arrays are passed by reference in Java, it doesn't necessarily have to also be a return value. So I'm just going to start by extracting this method with the sequence as an input and no return value. Okay, so the way to do this is to cut the code of the method and replace it with a reference to the new method. Let's call it populate sequence, that you want to call. And as I said, sequence is an input, so let's put the input value in first. So we start by creating a reference, an invocation of this method that we're going to extract, and then we're going to create that method and paste our code into it like that. And theoretically, when I rerun the tests, that should still work. Lovely. Yeah, let me just clear up that to do there. To-dos in code never get done, so get rid of them straight away if your tool is generating them. Now I could clear this up a bit. I could actually have this return statement do the whole thing, so return populate sequence. But in order to do that, this has got to return an actual sequence. So let's change the signature of this method to return the sequence first of all, and let's just check changing the signature of the method. So I'm thinking in terms of individual refactorings. I extracted the method, then I changed the signature. I can inline this now, populate sequence. I should really have done a cut there, that would have been quicker. So having inlined that now, I've now got the get sequence method down to something very, very simple. My populate sequence method, it's still a decision inside a loop, and ideally I'd only want one of those things inside each method. So I'm going to break it down even further now, and I'm going to extract this block of code, this if statement, into its own method. Similar kind of thing here. I need to identify potential inputs and outputs. Again, the sequence has to be an input, but also the index I has to be an input. So let's extract this into a method by, again, we'll cut it, we'll replace it with a reference to that method. Let's call it fill item, just for jolly. And as I said, we need to pass in the sequence, and we're also going to need the index I for this method to work. Okay, and now let's declare that method, and we'll paste our code into it. And again, that's extract method. We run the test to make sure it still works, and let me clean that off to myself there. So even though I'm doing these refactorings manually, it's very, very important to be clear of the mechanics of each refactoring, to sort of name it in your head. I'm extracting a method, I'm renaming a class, I'm inlining an expression or a variable or something. So be very clear of what the refactoring is you're doing, so that you can be sure by knowing the mechanics of that refactoring when you're done, and therefore should be able to run the tests. So there you go, that's manual refactoring. What if you're on my training courses and you're doing manual refactoring, or even if you're not doing manual refactoring, it can be good practice to practice doing a range of refactorings manually. So try some of the most common ones, like extract method, extract interface, extract class, rename. That's a fairly easy one you can do with sort of find and replace. Inlining, creating local variables from expressions or literal values, and the things that tend to come up a lot. Basically, try doing them manually. It'll help you wrap your head around the mechanics of those refactorings. But also, if you are ever find yourself having to refactor without automated refactoring tools, it's very, very useful to know how these things are done manually and be able to do it in a more disciplined way. Okay, thank you very much.